Okay, so here is AP Stat Quideo 2. The basic question is, here are Professor Moore's times in minutes to swim 2,000 yards and his pulse rate after swimming in beats per minute for 23 sessions in the pool. So then it gives us the 23 different sessions and it gives us the time for it and his pulse rate after that time. So what I did was I plugged this into the calculator. Well, first I set it up where I sorted it because it was a lot easier to look at when I put all the times on one side and all the pulses on another. And then for time's sake, I'm not going to enter it all into my calculator again, but I put the times under list 1, and then I put the pulse rate under list 2 in the calculator. And then it was determined that yes, a linear model can appropriately model this data, as there's a distinct line that the data follows, and the equation for the line, which I found by plugging in the values and then doing stat, calc, and then linreg, got me the answer y hat equals negative 9.694x plus 479.93. And this equation was what I used for question B, which was the next day's time is 34.3 minutes. Predict the professor's pulse rate. His actual pulse rate was 152, and how accurate was your prediction? So I plugged the 34.3 into the equation that I got in number 1, so I did negative 9.694 times 34.3 plus 479.93. And I got 147.4258. The prediction was pretty close, like only around 5 beats off, but it could have been slightly more accurate. And then for letter C, sorry. For letter C, I was told that the pulse rate was 152. Now I want to predict the swimming time, so I fill in the same exact one as before, but I do it backwards, so I'm given the answer and I have to figure out what x is, and I get x to be 33.83 minutes, and it was very accurate because the appropriate time was 34.3, so it was only 0.47 off. And question D is explain clearly to someone who knows no statistics why there needs to be 2 different regression lines for parts A and C. And that would be because there are 2 different variables, so you have to show 2 different lines. The advanced question is, to the right are data collected on the prices and capacity of hard drives. Below is the regression analysis of price versus capacity. And so we're given the data they collected, and we're also going ahead and given the intercept and the capacity. So we're given the materials used to make the equation. So we know that I wrote all these valuables down again just so I would have them, and then I wrote all the values out in a little list because I like to be organized. But so the first thing asks us to define our variables and then make an equation without using a calculator. And since we are given the variables right up here where the intercept is 18.617 and the capacity is 103.929, we can use those 2 values to make the equation, which we get y hat equals 103.929x plus 18.6172. The slope would be the 103.929, which suggests that the price increases with each terabyte as around $100. Starting the price is around $18.63. For C, we had to plug in the number 3 for X and determine around the cost of the 3 terabyte hard drive. So I did 103.929 times 3 and then added that to 18.6172, and the predicted price was around $330.40. And this was in D, Mr. Shaheen bought it for $300, so that was a good buy because it was for $30 cheaper than the predicted price should have been. The AP question states, windmills generate electricity by transferring energy from wind to a turbine. A study was conducted to examine the relationship between wind velocity in miles per hour and electricity production in amperes for one particular windmill. For the windmill, measurements were taken on 25 randomly selected days, and the computer output for the regression analysis was for predicting electricity production based on wind velocity as given below. The regression model assumptions were checked and determined to be reasonable over the interval of wind speed represented in the data, which were from 10 miles an hour to 40 miles per hour. And so it gives us the coefficient, it gives us all these values, r squared, okay. So we use this data to determine the equation of the least squares regression line and identify the variables used in the equation. So the predicted electricity production is represented by the equation 0.24x plus 0.137. And 0.24 is going to represent the wind velocity coefficient, which we are given right here. And the 0.137 is the constant coefficient, which we are given right here. So we use these two values to make our equation. And then for B, how much more electricity would the windmill be expected to produce on a day when the wind velocity is 25 miles an hour than on the day when the wind velocity is 15? So what we can do is we can plug both 25 and 15 into the equations and get their values. So for 25, the value ends up being 6.137, and for 15, the value is 3.737. And then to see how much difference there is, we would just subtract one number from the other. So the difference is 2.4 amperes. So there's 2.4 amperes more electricity produced on a 25 mile per hour day. And then C, the chart given shows that r squared is 0.873. This is the proportion of electricity production to wind speed, which is shown by the linear relationship between the data. So wind speed and electricity produced have a direct correlation. Thank you.